Polyatomic ions are nonmetals that are covalently sharing electrons, but are an ion because they either had to gain or lose electrons to form this compound. Most of the time, it's a nonmetal with multiple oxygens. When you have a polyatomic ion with a metal, you still have an ionic compound. Because a polyatomic ion has a negative charge and a metal has a positive charge, you're transferring electrons and you have an ionic compound. And the naming works the exact same way, except for you leave the ending of the polyatomic ion specifically. For example, let's say that you have NaNO3. If you look at your periodic table, you know that's sodium. And if you look at your polyatomic ions, you see nitrate NO3s here on the bottom, so sodium nitrate. Another example could be Cu2SO4. Okay, so I know that Cu is a transition metal. Can be +1 or +2. SO4 is right over here. So I have the 2, if I change the color here, that comes from the sulfate. So since there's no other subscript after the sulfate, it's just SO4, it's like there being an invisible 1, which means that you have copper +1. So the name of this would be copper 1 sulfate. Another example could be something like this. You could have Fe3PO4 Now you see, all right, where's my phosphate? My phosphate's over here. The 3 comes from the phosphate, the 2 comes from the iron. So I'm dealing with iron 2+. So the name would be iron 2 phosphate. Now, only knowing the polyatomic ions is not enough because there's certain rules that happen when there's a hydrogen added to a polyatomic ion or oxygens are lost. So, for example, if you look at the example right here between carbonate and hydrogen carbonate, so you see that CO3 2- is named carbonate. But all of a sudden, you have HCO3- below that. Well, the reason that it's minus is because every hydrogen is a +1. So +1 with -2 is still a -1 charge. So it's still a polyatomic ion. And you think that on the inside, it's covalent. It's like a molecule. So you name it like this. You name the hydrogen, and then the polyatomic ion, carbonate. This can then, because it's an ion, still bond with a metal. So let's say you had something like this, NaHCO3. So you'd identify, all right, I have a +1, my metal here, and then this has to be my polyatomic ion. So this would be sodium, hydrogen, carbonate. And this can apply to all of the polyatomic ions. Knowing that every single hydrogen that you add is a +1. If you all of a sudden add enough hydrogens, if I added 2, I got H2CO3, I no longer have a charge because I added 2 hydrogens, so that's +2, and I was a -2 charge. So I'm neutral compound, so now I'm an acid, and this would be called carbonic acid, following the rules of naming acids, changing the ending to IC from the polyatomic ion. Then one more thing, going over here, when oxygens are lost, we call these, most of the polyatomics are oxyanions, nonmetal with multiple oxygens. So what can happen is you can add oxygen or lose oxygens, and then the names change because you have to indicate through the name how many oxygens you kind of have. So let's look at chlorate for this example. ClO 3- is chlorate. That's your base. Your base is always the one that has all the oxygens, and then you can either go down or up. Chlorate is a very special example. There's not that many that can go up, but know that that's your base. So if I added an oxygen, ClO 4-, I would have to add a suffix in front of the name. So it would be perchlorate. Now, if I lost an oxygen, ClO 2-, the name would change to chlorite. So just my ending changes. The I tells me I lost one oxygen. So instead of being the base, I am the base with one less oxygen, and my name ends with an ite. Then you can do one more, and you can lose more than one oxygen. To then indicate that you lost more than one, you have to include the suffix hypo, and then the ite ending. You have to include the prefix hypo and the suffix ite to indicate this was losing an oxygen, and hypo means more than one, so you lost more than one oxygen. Then naming these with ionic compounds is the exact same way. For example, if you have, let's say, MgClO4-2. It's ionic. You know that magnesium is one of your main group elements. The 2 comes from magnesium. The invisible 1 comes from perchlorate. You remember that ClO4 is not your base, so you must have added an oxygen, so this would become magnesium perchlorate. So it's important to know how these oxyanions and polyatomic ions, whether a hydrogen's being added or you're losing or gaining oxygens, the name changes to indicate exactly what you have.